let us continue with the biconditional operator, which is represented like this: A, double arrow, and then B. Read it as biconditional, or it is also called as double implication. Now the meaning of double implication is implication in both the directions. So A double implies B can be broken as A implies B and B implies A. That's it. Once you break double implication like this, double implication will be converted into a problem of implication and their ending. So double implication is nothing but ending of or conjunction of two implications in one direction. These are single-sided implication. This is a double-sided implication. Now let us see what will be the meaning of A double implication B. See, A implies B means A only if B, and B implies A will mean B only if A. And if we combine these two, A only if B and B only if A, we will get a statement A if and only if B, and therefore this will be simply called as A if and only if B. Now when I say A implies B, there B is the necessary condition for A, and when we say B implies A, here A is the necessary condition for B. See, B is necessary condition for A, and here A is necessary condition for B. A is a sufficient condition for B and B is a sufficient condition for A. Now if we combine these two, like A is necessary condition for B and A is sufficient condition for B. Again I am saying once again, see, B implies A means A is a necessary condition for B, and A implies B means A is a sufficient condition for B. So A is a sufficient condition for B and A is a necessary condition for B, and this can be written as A is a necessary and sufficient condition for B. Similarly, we can write down in the other direction also. How? Here B is a necessary condition for A and here B is the sufficient condition for A, and this has been ANDed. So B is a necessary condition and B is a sufficient condition for A. So we can write down B is a necessary and sufficient condition for A. And from these two, A is a necessary and sufficient condition for B, then B is a necessary and sufficient condition for A. If we combine these two sentences, then we can write down A and B are necessary and sufficient conditions for each other. So that is the first conclusion that we can say. Whenever you have A double implication B, it means A is a necessary and sufficient condition for B, B is a necessary and sufficient condition of A and B are necessary and sufficient conditions for each other. Second thing, if A then B can be written as B if A, and B implies A can be written as A or B only if A, because here A is the necessary condition for B. Here it is different. Here I am writing down B is A because B is to the other side, B is to the then side. So B if A means if A then B. But here A is the necessary condition for B, and therefore I am writing down B only if A. And now you tell me what will be the result. B if A and B only if A. What I will do, B if A and only if, okay, A I will write it down outside. So this will become B if A and B only if A. If you combine it together, that will be called as B if and only if A, and I hope this can be very well written as B if and only if A. That means this is one way to write down A and B are necessary and sufficient conditions for each other. This is another way to write down B if and only if A. And similarly, if I change the sides, I mean here I can write down A if B, and here I can write down B only if A, and therefore similar way you can combine. We can change the side and you will get A if and only if B. So another way to write down this sentence will be A if and only if B, or B if and only if A. That means A and B are necessary conditions for each other, and A and B cannot exist without each other. One of them is existing, one of them is not existing, will not be possible. Either both of them will exist or both of them will not exist. Now let us see the sentence that I am making. Either both of them will be there or both of them will not be there. This is very important. It means, let us go by an example. If I write down Sunday double implies holiday, that means Sunday if and only if holiday. Now what is the meaning of Sunday if and only if holiday? If it is Sunday, then holiday. If holiday, then Sunday. No Sunday, no holiday, no holiday, no Sunday. Sunday means holiday and holiday means Sunday. So basically, whenever you write down a double implication, you are trying to say Sunday is equivalent to holiday, and when Sunday is equivalent to holiday, that means holiday is equivalent to Sunday. That is, Sunday and holiday are equivalent to each other. And what does that mean? Sunday and holiday are equivalent to each other. Sunday means holiday and holiday means Sunday. Therefore, every Sunday will be a holiday and every holiday will be a Sunday. Sunday cannot exist without holiday. Holiday cannot exist without Sunday. Sunday means holiday. Okay, if Sunday, then holiday. No Sunday, no holiday. So let us see. Rather than analyzing this more in English, now we will try to analyze it with the help of logic. And what does that mean? We can draw truth table for double implication, and we will draw the truth table with the help of implication. So let us see. Sunday double implies holiday means Sunday implies holiday and holiday implies Sunday. That is the basic meaning of double implication. It is implication in both the sides. And let us take the variables Sunday, holiday. And here we will do the ending. Sunday implies holiday and holiday implies Sunday. Now let us give the values here. False, true, false, true. Okay. Now first implication, if Sunday then holiday. What does that mean? Holiday without Sunday not possible. Sunday true, holiday false, not possible. Sunday true, holiday false, not possible. So this row will be false, other rows will be true. Now if holiday then Sunday. If any day is a holiday, then that particular day will be a Sunday. Here, holiday without Sunday not possible. Holiday true, Sunday false is not possible. So let us see the row. Holiday true, Sunday false is not possible. So this row will be false and other rows will be true. And these two columns have to be ANDed to get the result of this third column, because we can see I will give numbers here. We will call it as 1, we will call it as 2, and here what we are doing, 1 ANDed with 2, and therefore let us see what is the result. True and true will be true, true false will be false, false true will be false, true true will be true. Now you ignore these columns for a moment and directly concentrate here. Whenever both are false, the result of the biconditional is true. Okay, so here I will also modify the name. The column that I have drawn is a biconditional. S double implies holiday. Sunday double implies holiday. It can also be called as holiday double implies Sunday. Now, when both are false, the result is true, and when both are true, then also result is true. When both are different, false true, true false, the result is false. What does that mean? No Sunday, no holiday, no holiday, no Sunday. If Sunday, then holiday, if holiday, then Sunday. Then holiday without Sunday not possible, Sunday without holiday possible. Every Sunday will be a holiday, every holiday will be a Sunday. Sunday without holiday is false and holiday without Sunday is false. Simply, very simply, you can simply say Sunday is equivalent to holiday, and when you say Sunday is equivalent to holiday, automatically holiday becomes equivalent to Sunday. Either both of them will exist or both of them will not exist. Exactly one of them exists, like holiday exists without Sunday is not possible, and Sunday exists without holiday is not possible. Both of them are present is possible, none of them is present is also possible. Both of them are absent, possible. Either both should be absent or both should be present. One of them present, other absent, or one is present, other is absent will not be possible. What does that mean? The result of biconditional will be true when both the sides are same. And when I say both the sides are same, both should be true or both of them should be false. And that is why we say that Sunday double implies holiday means Sunday if and only if holiday, then holiday if and only if Sunday. Third, Sunday is necessary and sufficient condition for holiday, and holiday is a necessary and sufficient condition for Sunday. And when I say Sunday is necessary and sufficient condition for holiday, I am making two sentences. Sunday is necessary condition for holiday and Sunday is a sufficient condition for holiday. Holiday is necessary condition for Sunday and holiday is sufficient condition for Sunday. Similarly, we can write down Sunday is equivalent to holiday, or we can also say holiday is equivalent to Sunday, and no Sunday is equivalent to no holiday, and last one, no holiday is equivalent to no Sunday. So the only important thing that you need to understand is biconditional is nothing but conditional in both the directions, and the value of biconditional will be true if and only if both the sides are same. I am saying both the sides are same. Same means both of them should be false or both of them should be true. So that was the biconditional operator. Now here we are done with all the operators, namely AND operator, OR operator, NAND operator, NOR operator, implication and double implication. Now just to summarize, AND, OR, NAND, NOR, all the four operators are commutative, that is A and B will be equal to B and A or B will be equal to B or A NAND B will be equal to B NAND A NOR B will be equal to B NOR A always. Now let us check the commutativity of implication and double implication operator. So how that can be checked? A implies B. Sorry, I need to take the values first. A implies B implies A. Now values false, true, false, true, false, false, true, true. Now A implies B will be false when A is true and B is false. This will be false, others will be true, and B implies A will be false when B is true and A is false. So second row will be false, all other rows are going to be true. And from this we can say that A implies B is not equivalent to B implies A, and therefore implication is not commutative. Similarly, let us check whether double implication is a commutative operator or not. For that I need to do simple modification here. We will make it double implication. Here A double implies B and then B double implies A. So I am changing the side and let us see what will be the truth values here. So double implication, when both the sides are same, result will be true. False, false, true, false, true, false, true, false, false, true, true, true. Similarly, B double implies A, false, false will be true, false, true will be false, true, false will be false, true, true will be true. And from these two columns we can say that double implication is commutative. So here is the first major difference that you should remember between implication and double implication. And what is that? Implication is not commutative, but double implication is commutative, because double implication talks about equivalence and equivalence is also commutative. See, whenever A is equal to B, you can always go and say B is equal to A. In double implication, whenever A is equivalent to B, then B will also be equivalent to A. And whenever A is not equivalent to B, that means B is also not equivalent to A. Equivalence is symmetric, therefore biconditional is also symmetric, and therefore the biconditional is a commutative operator. Apart from that, okay, so what is the conclusion then? We have seen AND, OR, NAND, NOR, implication and double implication. As far as commutativity is concerned, AND is commutative, OR is commutative, NAND is commutative, NOR is commutative, double implication is also commutative, single implication is not commutative. Remember it very well. Commutativity, this property is not satisfied by single implication, but it is satisfied by double implication. Now let us check one more important property of operators, that is associativity. we will check for all and, or, NAND, nor, then okay. Implication and double implication we will not check the associativity. For this we are going to check. Now first of all, what does associativity means? See, an operator is associative if and only if for any A, B and C, A star B star C is always equal to A star B star C, without worrying about the values of A and B and C. You don't know what are the values of A, B, C. For all possible values of ABC, for any values of ABC, A star B star C must always be equal to A star B star C. I will write down equal to rather than equivalence. Now what does that mean? If you change the grouping here, the only difference is that of grouping. What we are doing here, we are performing the operation on A and B, and then the result is being operated with C. Here, first of all, we are performing the operation of BC, and then the result is being operated with A. Okay, so this is what is called as associativity, and as you may see, in order to check the associativity, we need at least 3 operators, and therefore I need to draw a truth table of 3 variables. So let us go for A, B, C, and we will check the implications. First of all, A and B and C like this, and then we will give for A and B and C. And what we are going to do, we will take the values as usual: false, true, false, true, false, true, false, true, false, false, true, true, false, false, true, true. Then false, 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 true, 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 true. Okay. Now in both the cases, here first we will add BC. So BC will be false, false and false will be false, 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 true, false will be false, false, true will be false, false. First I am ending BC, false, true will be false, false, true will be false, and true, true will be true. As you can see, whenever you are ending 3 operators, the result is true when all of them are true. Similarly, now here we will end AB first, and then we will end the result with C. So false, false will be false, 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 false. Here the result is true, but this is false, so true, false will become false. Here true and true will be true. So everywhere you are going to get false except the last row. And what does that mean? That because both these columns are same, we can say that A and is an associative operator. Similarly, or is also an associative operator, because if you observe in both the cases, A or B or C, A or B or C, whenever you see a true, the result will immediately become true. So what we are going to do here, we will first of all check B or C. Now B or C is false, this is also false, therefore the result will be false. True, true, true. Now this is false, but this is true, therefore this will be true, 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 and true. Similarly, this is false, this is also false, therefore the result will be false. Then this is false, this is true, therefore the result will be true, 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 and therefore all the rows are going to be true. Okay. Now, in order to check whether NAND is associative or not, I am going I will follow the method of contradiction. And what does that mean? See, first of all, we will draw the tables for NAND. Let's take the values. Now here NAND will be true, true, true will become false. These are all going to be true. Now in case of NOR, it is negation of OR. So true, false will be true, negation will be false, false, false and true. Let us see what we are going to do. True NAND, false NAND, false, and then we will check true NAND, false NAND, false. Let us see what is going to happen. Here true NAND, false. True NAND, false, the result will be true NAND, false, and true NAND, false, again the result will be true. But whenever you do false NAND, false, false NAND, false, the result will be true. So this will become true NAND, false, and false NAND, false will be true. And whenever you do true NAND, true, the result will be false. Now see, whenever you NAND this bracket first and then the outermost add, the result will be true. But whenever you bracket this first and then this T, the result is coming out to be equal to false. And simply looking at this example, see what I have done, this, then this, then this, and this is one track that we have followed. Here the result is true and here the result is false. And therefore we can conclude it's a contradiction. If NAND were associative, then these results will not be different. Results are different and therefore we can say that the NAND operator is not associative. Similar contradiction can be applied for NOR, and we can see that NOR is also not associative. So NAND and NOR operators are not associative and OR operators are associative.